Alright, Algebra 2, this is your last video of the year, trig video number 4. This is the law of cosines and the law of sines. Now, the law of cosines will be used on non-right triangles, although you could use it on right triangles, but then it just turns into the Pythagorean theorem, and I'll show you that later. So I'm sure that doesn't make any sense at the moment. The law of sines can be used on any triangle, not just right triangles. And it's useful in a lot of different ways. So let's look at an example here. Before we do that, I want to show you what the law of sines actually states, and then we'll get into a couple examples here. It says that the sine of angle A divided by its opposite side. We use capital letters for angle measurements and lowercase letters for sides. So this is the side opposite angle A. Capital letters are for angle measurements. Back up this a little bit. And lowercase letters are for side lengths. Those side lengths do happen to be opposite of the angle measurement. So we have the sine of angle A divided by its opposite side equals the sine of angle B divided by its opposite side. Now you could clearly see that this is a proportion, and we know how to solve proportions. We cross multiply, and so that's what you'll be doing in a lot of these situations, or in all of these law of sine situations. There may be one extra step, and that comes if you're trying to find an angle, but we'll talk about that when we get there. So here's example 1. Find a side. Zoom in a little bit there. In triangle PQR. Okay, first thing I want to do whenever I see these situations and they have not drawn a picture for me is I want to draw a triangle. Now, you'll notice that I drew a triangle and I had no idea whether it looked like the right picture or not. Guess what? That's how they got away with murder in geometry, right? Because they always said, not drawn to scale. So that's what I'm going to say, not drawn to scale. So I can draw the triangle however I want, even if these numbers that I'm going to put in this triangle don't make sense for the picture, right? If I get an obtuse angle, obviously I drew something that almost looks isosceles, maybe even equilateral, but definitely probably not going to fit what I'm going to put in it. So let me put in the information. Angle R is 39 degrees. Angle Q is 32 degrees. And angle PQ, or side PQ, is 40. Side PQ is equal to 40. Now, the key to being able to use the law of sines is that you must have a known angle. Okay, this is so, let me write down requirement. Requirement. Sorry, my E got crunched in there. Known angle and its known opposite side. I don't need an apostrophe. What was I thinking? Known angle and a known opposite side. Okay, so I clearly have that situation sitting in front of me. And I'm trying to find RQ, it says. Find RQ. Well, so I can do the sine of angle 39 divided by its opposite side, but I'm trying to find side RQ. Do I know the angle across from it? Well, at first it looks like I don't know that angle, but I really do, because I have two angles in the triangle. So, using my powers of geometry and knowing that triangles all add up to 180, I can see clearly now. Sorry, let me start back over. I can see clearly now the angles come. All of the angles add up to 180. Sorry. Let's see here. 71, so 180 minus that answer gives me 109. Clearly, this triangle is not drawn to scale. But we need the sine of angle 109 divided by its opposite side. Now, I'm going to label it x just because I didn't want to write RQ in there, but that's what we're finding. So here comes my cross multiplication, right? 40 times the sine of 109. Ooh, I'm off screen. Let me move up. There we go. 40 sine 109 divided by sine 39. Gives me 60.1. So 40 times the sine of 109 divided by the sine of 39. Boy, if you cancel out those trig function sine, man, the red pen of death is going to come after you, because that is not correct. You do not want to get rid of that trig function. It's not like a variable that you can cancel out. I know some children think so, but hopefully not you. Example 2. Example 2 says find side KL. Okay, so another one of these situations, I see a known angle and a known opposite side, and I'm trying to find side KL, which we already know the angle opposite it, so that's kind of nice. So we have the sine of 120 over its opposite side equals the sine of 50 over its opposite side. Okay? And so now we're going to do the same thing we did before. Nothing tricky about it, right? 35 sine 50 divided by sine 120. For argument's sake, since we're rounding to the 10th spot, that looks like 31. Okay, now, this next example is a little bit different because you're going to actually find an angle for me. So, in triangle RST, which obviously is not drawn, so let me draw it here. Side T is 7. Okay, they use lowercase t. That way I knew it was opposite angle T. Lowercase r is 9. All right, so that's 9. And the angle R is 110. Find angle S. Okay, we're going to find angle S. So, angle S. Let's go with angle T. Sorry. My bad. Angle T. So the sine of 110, yeah, sine of 110, sorry, thinking in my own mind, is equal to the sine of angle T over 7. Sine of angle T over 7. And we're going to cross multiply like we did before, right? 7 times sine 110 divided by 9 equals sine t. Now, the reason this situation is different is because we don't have t by itself. We're going to have to do one extra thing here. So when we do 7 sine 110, and then we divide that by 9, we end up with 0.73. Well, the angle is not 0.73 degrees. That is the sine of the angle. So the sine of angle t is approximately equal to 0.73. So how are we going to get t by itself? Well, the only thing you can do, remember how to find an angle? You have to use the inverse function. So in this case, it would be the inverse sine. So we're going to use the inverse sine of the answer. That'll give us the most accurate angle measurement. So for all intents and purposes, since we're rounded to the 10th spot, 47 degrees. Now, The next equation that we're going to deal with is the law of cosines. Well, look at this equation right here. That's not the law of cosines. That's the Pythagorean theorem, right? Well, interestingly enough, the Pythagorean theorem is a special case of the law of cosines because you never saw this extra term sitting there, minus 2ab cosine c. And the reason you didn't see that is because angle C is a 90-degree angle. And we all know that the cosine of 90 degrees, according to our unit circle, which we just went over, that's the x value at the top of the circle is 0. So when you plug 0 in here, right, what does that do to this whole term sitting over here? It wipes it out. Therefore, you have what we call the Pythagorean theorem. All right, so law of cosines is a more general equation, and the Pythagorean theorem is a specific part of that. Well, we might have a triangle that looks like this. Notice we got angle A, B, and C, and side A, B, and C opposite those angles. So what I want you to do is I want you to look at this equation, right? I want you to notice that on the left side is a side length squared, and on the right side, on the other opposite end of the equation, is the cosine of the angle C, which is opposite this side. Now, one of those two, either this side or this angle, is going to be the variable. One of them. I guarantee you one of those is your variable. If the other letters end up being variables, then you're using the wrong formula. Okay? When do we use the law of cosines? If we can't use anything else. So, for instance, I told you that the requirement for the law of sines was known angle, known opposite side. If I have that situation, I'm always using the law of sines. But if I don't have that situation, I'm definitely using my backup plan, which is the law of cosines. I'm going to get into this example here in a minute, but class is about to start for a different class, so I'm going to have to pause. All right, so we're back to finish these last few examples here on the law of cosines. There are a couple different situations we're going to do, and the first one is the fairly easy one. So I'm dealing with a side, an angle, and a side, just like you might have described in geometry, side, angle, side. That situation is what we're dealing with. I told you that one of the ends of the formula would be your variable. Okay, so here I have my law of cosines. I can clearly see that there is no known angle and known opposite side, so I can't use the law of sines, otherwise I'd be using that. So let's see here. What's going to be my variable? I told you one of these two at the ends would be my variable. It looks like what I have is a side length A and the angle across from it. So A will be my variable over here, and the 40 is on the opposite end of the equation. Then I can fill in the other two sides. It does not matter which one you put where, as long as you have a 3.5 and a 2.5 and a 3.5 and a 2.5. All right, so now we're going to use our calculator here to do the rest of the work. 3.5 squared plus 2.5 squared minus 2 times 3.5 times 2.5 cosine 40 degrees. So a squared is 5.09 approximately. Yes, I will take the square root of both sides. So a will be approximately equal to 2.26. Now the next situation is not side angle side, it is the side version. And we're trying to find angle C. So These are the two we're dealing with. So 12 is going to go on this end of the equation, and C, angle C, is going to go on the opposite end of the equation. I guaranteed you one of those would be the variable. Now, it doesn't matter what you call the other spots as long as you've got a 5 and an 8 and a 5 and an 8. Now, before we finish this question, I want to do a simpler question to see or to remind you so you don't make a common mistake. Take a look at something as simple as this. Now, what are you going to do to solve that? Well, the first thing we do is we would combine the 2 and the 3, right? Is there anything in your mind that would make you take 5 minus 7 right now? I hope not. But there are lots of kids who will do this, and it's a critical mistake. Now, I'm not allowed to do that because one is being multiplied times x and the other was not. In other words, these are not like terms. We cannot add unlike terms together. So we must subtract that to the other side. And when we would subtract it to the other side, we would get something like this. After which we would do division in order to finally arrive at our answer. But there's nothing in the universe which should tell me that I should put those two things together. That's a violation of the order of operations, and you don't want to do that. So let's go back to the question I have here. There are really three things that I have going on here. So there are really only three steps. I've got this, which is not a like term to the other because it's got cosine C sitting over here. I've got something else to deal with right here, and then lastly the cosine. So there are really three things to deal with. So I'm going to take my calculator. Now what am I going to do with this thing? The first thing I'm going to do with this thing is subtract it to the other side. So watch how I do that. 12 squared minus parentheses. Use parentheses when you want to subtract a sum. And you'll notice that I didn't even calculate 12 squared, even though I know that's 144. 5 squared, which is 25, and 8 squared, which is 64. I didn't even calculate them. So bringing that over to the other side gives me 55. So I know that 55 is equal to negative 2 times 5 times 8 cosine C. Now I need to deal with this part. Yes, I'm going to divide it to the other side. So we have 55 divided by, parenthesis, negative 2 times 5 times 8. Please notice I didn't even calculate that that was negative 80. All right, I'm leaving the calculator do the work for me, but I'm using the parentheses. So I end up with negative 0.6875. There's only one thing left to do. In order to get C by itself, I have to invert the cosine. So if I invert the cosine of negative 0.6875, I'm going to have my answer. Since I already had that number in my calculator, I'm just going to use the answer feature. So C is a 133.4 degree angle. Whoa. That's so you can see more of the work. Sorry. Okay. Example 3. Another one of these situations, it's another side situation. It says find the largest angle. Well, the largest angle would happen to be opposite the largest side. So when I go to fill this out, 15 goes over here and angle B goes over there. That's the most important decision you have in using the law of cosines. The other two sides doesn't matter. I got 10, 14, 10, 14. So we're going to subtract this. We're going to divide by this. And we're going to invert the cosine. Three things. 15 squared minus, parenthesis, 10 squared plus 14 squared. That's negative 71. Then I'm going to divide by, parenthesis, negative 2 times 10 times 14. Then I'm going to invert the cosine. Angle B is a 75.3 degree angle. Approximately. Three things. Subtract, divide, invert the cosine. Talk to you in class.